Hello, welcome to lecture 10. Today I am going to talk about number system. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. So we will talk about numbers. So I draw a line. This line is called the real number line. That means any number. There are various types of number which we will describe below. They can be plotted on this number line. This is 0. This side is positive numbers and left hand side of zeros are negative numbers. So how many types of real numbers are there? There are natural numbers which you count using a finger 1, 2, 3 and so on. Then there's a whole number, you add 0 to the natural number, then it becomes a whole number. And if you add all the negative numbers, then it is called the integers. And if you take ratios of the numbers, either negative or positive, this is number any integer, divided by any other integer, then these are the fractions. And this any number which can be represented as this fraction are called rational numbers. And then you have irrational numbers. These are like square root 2. These are the numbers which you cannot represent by fraction. So since it cannot be represented by a fraction, the decimal expansion will be non-terminating. We will see what you mean by decimal expansion which is terminating and non-terminating. If decimal expansion is terminating, then you can represent as a fraction. We will come to it. So if you take a collection of all real numbers which I have shown above in the line, then the smallest subset is a natural number. Then if you add 0, then this big set becomes the whole number. Then if you add the positive and negative integer, they belong to a bigger set. And then there is a rational number, or that is those fractions, either positive fractions or negative fractions. They are called as rational numbers, and the remaining ones are all the irrational numbers in this collection of this real number. So you denote natural number by n, the whole number by w, integer number by z. This is an integer set, and the rational number by q, and irrational number as q prime. Some people use different notation also. So if I now make a real number tree, so this real number is divided into these two branch rational numbers. This is the fractions, and irrational numbers. That is, it cannot be expressed as the ratio of two integer number, okay, such as pi or root 2. And this rational number is again divided into two branch called fraction and integers. Fractions are this, and integers are minus infinity to plus infinity, and 0 is here. Then you have these integers can be again subdivided into negative integers. This is this negative integers and the whole number, okay, 0, 1 to infinity, and this is minus infinity to minus 1. And then this whole number you can again break into 2, this is 0, and natural number, that is from 1, 2, 3. And this natural number can be either prime or can be composite or can be even number or can be odd. This all you have studied in your lower classes. Now we will describe how you represent a number. Say this is number 5.37 and over it there is a bar, that means 7 is repeating, that is 5.3777 is something like this. Then how do you plot this point, this number in a number line? So I go to number 5 and number 6. So this is 5.5. So this is between 5.3 and 5.4. So somewhere here it is. Then I go between 5.3 and 5.4, again divide into 10. I have here 5.37, that is 5.31, 32, 33, 34, 35, 36, 37. So this is between 37 and 5.38 because it is 5.377. So now again you break 5.37 and 5.38 into again 10. So again you take 7 and this is 5.378 and this is 5.377. So if you go on doing it, you will come closer and closer to this value 5.3777. Okay. And how do you represent say irrational numbers, say square root 2 or square root 3 on a number line? We will see this in discussing the Cartesian coordinate, but let us introduce the Cartesian coordinate here. So Cartesian coordinates consist of two axes, that is x axis and y axis. Okay, y axis is perpendicular to the x axis. and this is a 0, so this is a number line. All integers have plotted here 1, 2. So, and here also similarly 1, 2. You divide, this is all equal length. There will be, here it will be -1 in the left hand side. This is called the first quadrant, second quadrant, third quadrant, and fourth quadrant. So similarly, negative y you will have, this is 0, so below 0 you will have negative y coordinates, and left hand side of 0 you have negative x coordinates. So I take 1 in the x direction, and 1 I move 1 in the y direction, and I call it as 1, 1, because I have moved x1 and then I have moved y1. So you have, this is the distance r, and this line is perpendicular to the x-axis. I use Pythagoras theorem, that is sum of the base square plus height square is equal to hypotenuse square. Okay, this r is the hypotenuse. So this is 1 square plus 1 square is equal to r square. So if I write, here I have written here a square plus b square is equal to c square. This is the Pythagoras theorem. So a is 1, b the height is 1, is r. 1 square is 1, 1 into 1 is 1. So this 1 plus 1 is 2. So this is your, so r will be square root 2. And this is approximately equal to, you use calculator and you will find this value. So now since you have this r as square root 2, you draw an arc and mark it on the number line here. So this value is root 2. So similarly you can also do square root 3. This is now, you know, this is root 2 in this x-axis. You go up again 1. So this is root 2 square plus 1 square. This is r prime. So here 1 square, root 2 square is 2. Root 2 into root 2 is 2 is equal to r prime square. So r prime is equal to, this is 3, 2 plus 1 is 3. R square is 3, so r prime will be square root of 3. And square root of 3 you can use calculator and find it. So this is how you plot square root numbers in the number line. Similarly, you can do for square root 4 and square root 5. So how do we find the decimal value of this fraction 10 by 3? So I draw something like this, and here I place the dividend, and this is the divisor, 3, this is the divisor, and I get a quotient and a remainder. So this is 10, 3 goes in 10 3 times, so it is 9. So I subtract, I get 1 here, I add 1 0. Again, once I start adding 0, I have to put a decimal point. Then again 3 into 3 is 9. Then minus, only one time you have to put decimal. Whenever you add a 0, at that place you put a, so if you go around doing it, this is going to repeat. So this is 3.333, I put 3 dots, or in abbreviation you can write 3, this the decimal point, 3 and bar, that means this 3 is repeated. So similarly 7 by 8, I write this dividend here, divisor here, okay, 8 goes to 7 0 times, okay, so 7 minus 0 is 7. Now I add 0 here, so I put a decimal point, okay, then 8 goes in 78 times, 64, so I minus, then 6 I get here, I add another 0. So I keep doing this till I get 0, or I repeat this number, okay. So here it becomes 0, so this is a terminating, a decimal expansion. This is non-terminating, here it is. So similarly for 1 by 7, I write the dividend here, divisor. So 7 goes 0 times in 1. So 7 times 0 is 0. So you subtract, minus, this is 1. Then you add a 0, so you put a decimal point. So now 7 goes in 10 one times. So you keep doing it. You get 7 into 1 is 7, 30. So you keep doing it here till you get this one repetition, okay. So it is 1, 4, 2, 8, 5, 7, then again this 1, 4, 2, 8, 5, 7 will keep repeating. So I put 3 dots for repetition, and so I write the repeated one as 0.142857, and I put a bar on top, like here, 3 is repeated. Okay, this you all have studied in your very lower classes. So let me not waste time in this. Now we'll take some example from your book, example 1.7, that it says express 0.33, that is 0.3 this bar which is repeated in the form of p by q, where p and q belong to z and z is an integer and q should not be equal to 0. I can write this 0.33 is equal to, say it is x, then I multiply this 0.33 as 10 times this x, so that becomes, this decimal place will move one side towards the right. If it is multiplied by 100, it will move 2 digit to the right. If it is divided by 10, this decimal place will move 1 digit to the left. If it is divided by 100, 2 digit to the left. That you might have studied in your lower class. So now this 0.333 multiplied by 10, I get 3.333. And now this is for our sake, for individual, this is I am writing minus x here. That is this number, and minus this one I get 3 here, and then plus 0.33 I get this number. So if you multiply x with 10, you will get this decimal place will move 1 digit to the right. So it becomes 3.333. So now what I get is here, this is 3 and this 0.33 is x, which I have written here, 0.33. So I have a equation 10x minus x is equal to 3. This x goes to the left hand side, the plus x become minus x. That's why I have written 10x minus x is equal to 3. Then 10x minus x is 9x is equal to 3. So x is equal to 3 by 9. Okay, that is equal to 1 by 3. So this x is equal to 1 by 3. So I can write 1 by 3 is equal to 0.3 bar or this. So similarly, suppose another example 1.8, that is if you have a number 1.27 and 27 is repeating, I call it x. Now I multiply by 100, so I get 100x. So I have 127.2727, okay. So I take here 126 and 1.2727 I put it here. So I will get 126 plus x. I always have to have one x, okay. So this x. So I subtract this minus x here and then add it here to this, whatever I get this value. You go through it, please, and see how I do this trick. So now you have an expression 100x minus x, that is 99x is equal to 126. So x is equal to 126 by 99. So I write here x is equal to 126 by 99. I do the division and I get 14 by 11. Let us see whether this 14 by 11 is 1.27 to check it. So this is my 14, this is my dividend, this is the divisor, I put it here, and divisor I put it here. So 11 goes to 14 one times, so 11 ones are 11, this minus, I subtract this, 14 minus 1 is 3, now I add 0, so now you have to put a decimal place, so this becomes 30, 11 goes in 32 times, so 11 to the 22, so then I subtract here, okay. So 10 minus 2 is 8, 3 minus 3 is 0. Now again you add 0, okay, 80. 11 goes in 87 times, then you have 30. So now you see it is repeating, okay. So this, as soon as it starts repeating, you stop there and you say this is 1.27 and this 27 is repeating, okay. So we'll take another example, example 1.9, that is how do you express this 0.235. This 35 is repeated now. So I again multiply this number, this I call it x, 100 times x is equal to, so 2 decimal place it will move, so it will be 23.53. Again, I know this 0.23535, so I subtract this one, I get 23.3 and add this number, so I will get this number, okay, as we did earlier. So now it is 23.3 plus x. X is this number. So now this 100x minus x is 99x, okay, and this is now 99x is 23.3. So I take this decimal place, I multiply by 10 and divide by 10. So it's 233 by 10. So x is 233 by 990. Again you do here, I have seen, you can freeze and see how I have done it, okay. Similar, I will not waste time doing the same thing again and again. So now we will find how to find square root of x for any real number, positive real number, geometrically. So you draw a line AB with measure x and then add 1 to it. So the diameter, I call this from AC as a diameter, and I take the radius as, this is x plus 1 is the diameter, so x plus 1 by 2 is the radius. So I take that radius and I draw a semicircle here, okay, and from this point B I draw a perpendicular line H. It intersects the circle here at point D. So here we write OB is equal to x plus 1 by 2, which is the radius, minus 1, that is OB, I write here. So this is nothing but x minus 1 by 2, and this OD is the radius is x plus 1 by 2, this is the radius. So here I know that OB square plus h square, I use Pythagoras Theorem, is OD square. Here OB square plus h square is OD square. So I can say that h square, I take this thing in the right hand side. So this OB is x minus 1 divided by 2 the whole square, I keep it here, and this OD is this. So this 2 square becomes 4. Here also 2 squares 4. I take 1 by 4 common. So this becomes x plus 1 the whole square minus x minus 1 the whole square. X plus 1 the whole square is x square plus 2x plus 1 square is 1. Minus of x square minus 2x plus 1. Now this x square get cancelled, plus 1, here it is minus, it will go here minus 1, so you have 2x plus 2x, and here is minus into minus is plus. We'll show why minus into minus is plus. So 2x plus 2x is 4x. So you get 4x divided by 4 is equal to x. So h square is equal to x. So h will be square root of x. So whatever number square root you want to find, geometrically you find this height, and you can measure with compass and mark it on the number line. So here one example I am showing you. They say find square root of 5. So x is 5, okay. The diameter is your x plus 1, and so the radius will be x plus 1 by 2 is the radius. So radius will be x plus 1 by 2, that is 5 plus 1 is 6, 6 by 2. So this is the radius is 3. 3 is the OD, okay. 3 is the radius, OD. And I know that OD square is OB square plus OA square. And what is OB? This OD is 3. So 3 minus 1 is 2. So OB is 2, 2 square plus h square. And OD is 9, 3 square is 9. So h square will be 9 minus 4, that is 5. This implies h is equal to square root of 5. So from geometrically, so you know OB, OD, draw perpendicular from B, which I had said, intersect the circle at D, and distance BD is h, this BD is h. Okay, now we can measure this h using compass, and take the compass, and from the origin you mark the square root 5, or this value of h, which is square root 5. Okay, so with compass measure h on number line from 0, mark it. Now in a number system we'll discuss what is base, what is power, and what is exponent. Okay, so any number to the power of n is represented as x to the power n. So when you say power, that is x, you multiply n times, x to the power n, where x is called the base, this x is called the base, and n is called the exponent. Here I have written symbolically, this is x to the power n is the exponent, and this is the base. So if n is 2, x square is x into x. If n is 3, x cube is x into x into x. So this is called x cube. The exponent tells how many times to multiply the number by itself. Okay, so if it is x to the power n, then it is x into x n times. If you have 2a to the power 3, this is 2a so 2a you have to multiply 3 times, 2a times 1 more time, second, third. So this is 2 into 2, 4, 4 into 2, 8, 8, a into a into a, 8aq. Okay, so before proceeding further, this is very obvious, but let us discuss it. We know that 5 into 3 is 15, and 3 into 5 is also 15. So how 5 into 3, this is, suppose these are 5 dots. If you make 3 times, if you take 3 times these 5 dots, it's 15. Or these 3 dots are there, if you take 5 times, So that also gives 15. Or in a number line, how do you see? Suppose you start with origin 0 here. Okay, so this is say division 1, 2, 3, 4, 5. So if you 5 into 3 means you jump 1 time, 2 times, 3 times. This 5 into 3 is 15. So similarly 3 into 5, you jump, this is 3. Then again jump one more 3. So you jump 5 times, you get 15. So this is what it means graphically. We should also state here that suppose this is minus 1 into a. That means whenever it is negative means you are going in the negative direction. So you move in the negative direction by amount a. So the value what you get is minus a. Or if you have say some positive value a and it says you move towards the negative value. Okay, this is minus means it is a negative value by this amount. So again you get minus a. So this example will make you more clear. Suppose you have minus 2 and then you say you go continue in the same direction, in the negative direction 3 times. So you get minus 6. And similarly I can also do minus 3 into 2, that is I go in the negative direction minus 3 and continue in the same direction too. So minus a into b or minus b into a, okay, they are same, is equal to minus ab. And we also know that multiplication is commutative. What do you mean by commutative? That is a into b is equal to b into a. That is 2 into 3 is 6 and 3 into 2 is also 6. So this is a commutative property. So similarly I can write this a into minus b. This minus b I can write as minus 1 into b. Okay, this minus a I can write as minus 1 into a. So then I can write a into minus 1 as minus a I will get, because it's a commutative, and then I will have again the same thing. Okay, so it is interesting to note that any integer multiplied by another number, any number multiplied by another number, suppose one number is negative, other is positive, the result will be a negative number. So minus into plus is always a negative and plus into minus is negative. This is just to show pictorially what it means. Otherwise you will always have a doubt what it really means. What is minus 1 into plus 1 is minus 1. Okay, so this gives you some understanding. So similarly I have written here some more thing. Let us skip this. I hope you have understood. This is a commutative property. Now let us discuss what is a negative number multiplied by negative number. So when you multiply two negative numbers, you get a positive number. How? We will see. We earlier saw a positive number multiplied by a negative number, or a negative number multiplied by a positive number. You will always have a negative number. But when you have a negative number multiplied by another negative number, you will have positive. That is minus into minus is plus. Okay, minus into minus is plus here. So how do you understand this? So by now we know that 3 into minus 2 is minus 6. I write this 3 as 4 minus 1 into this minus 2. This is also minus 6. So now I use a distributive property, that is a into b plus c is a into b plus a into c, which I write here. So here I write this 4 into minus 2 and minus 1 into minus 2. So I know that 4 into minus 2 is minus 8 and minus 1 into minus 2, I have put here question mark because I don't know what is minus into minus. And this is equal to minus 6, which I have taken it here. But you see minus 8, what you have to do to get minus 6? You have to add 2 here. Okay, this question mark, that is, it will be 2 plus 2. Okay, you cannot add any other number except plus 2. So this question mark is plus 2. That means this minus into minus, 1 into 2 is 2, we know that. So minus into minus is plus. So this is one way of understanding why minus into. Now this is the second method of proving that minus into minus is plus. This I can write minus 1 into 0. I know it is 0. So this minus 1 I write, and 0 is minus 1 plus 1. So I again use this distributive property. This minus 1 into minus 1 into plus 1 I write is equal to 0. Okay. Then this minus 1 into 1 is minus 1, I know. And this is minus 1 into 1. This is what we have to find out. Okay. I just take this minus 1 to this side, or I add plus 1 on both the sides. So these they get cancelled. So minus 1 into minus 1 is plus 1. So we can say plus into plus is always plus, minus into plus is minus, plus into minus is minus, and minus into minus is plus. So when I say this minus of some number and minus of another number, when you multiply it, it will be positive. So what is minus 2a to the power 3? So this is, I can write 2a 3 times 2a times minus 2a times minus 2a. So now I know that this is minus into minus is plus. So then plus into minus is minus. So I write here minus. And 2 into 2, 4, 4 into 2, 8, and a into a is 8aq. So my answer is minus 8aq. What is 2a to the power 4? Again I do the same thing. Okay, 4 times. Minus minus plus, plus into minus is minus. Again minus into minus is plus. Okay, so plus here I write. Then 2 into 2 into 2 into 2 is 16, a4. What is a square into aq? That is a into a times into, that is a to the power 5. So a into a square into a cube, I can write as a to the power 2 plus. And a square into minus a cube is what? This is a square is a into a, and minus a into minus a 3 times. So now I know this minus into minus is plus, plus into minus is minus. So I will have a negative sign, and there are 5 ways. So minus a to the power 5. Okay. So here, from here you can see that x to the power m into x to the power n is always x to the power m plus n. So now there is something called additive inverse. That is when you add two number, you get 0. So what do you mean by add two number? That is, I add x plus of minus x. So this minus x is the additive inverse of plus x. And there is something called multiplicative inverse. That is, when you have some number, you multiply by another number, then you will get 1. Okay, so suppose the number is x. So what is the number which you multiply to x to get 1? That is 1 by x. So 1 by x is the multiplicative inverse of x. Okay, so here actually if I take this x, this is in the denominator. If I take this x to the numerator, then my x to the power 1 becomes x to the power minus 1. If it is x to the power 2, then this from denominator to numerator, it will become x to the power minus 2, and so on and so forth. Okay, so I can write this as x into x to the power minus 1. This is power 1. Okay, when I don't write anything, means it's power 1. If I write 0, x to the power 0, that means x to the power 0 is always 1. Number to the power 0 is 1. So this is here, x means x to the power 1. So I can write using the earlier formula which we wrote, that x to the power m into x to the power n is m plus n, where m is here plus 1, n is minus 1. So this is, so x to the power 0 I get, and x to the power 0 is 1. So it is the same thing which I have said here, written here. Okay, x to the power 0, that is m minus m is 0, so x power 0 is 1. So any number to the power 0 is 1, even pi to the power 0 is 1, e to the power 0 is 1, 100 to the power 0 is also 1. So here I have introduced the number e. Okay, earlier we had introduced in the geometry section what is pi. What is pi? Pi is the ratio of the circumference to the diameter. That is 2 pi r times diameter is 2r. So 2 pi r divided by 2r remains pi. If you 2r cancels, you have pi. Okay, so definition of pi is ratio of the circumference or perimeter of a circle to its diameter of the same circle is pi. It's always pi. Whatever the circumference of the or diameter of the circle is, so if you take the ratio of circumference to diameter, you will always have a value pi. And what is e? E is also some universal number. We will see what e is. This is beyond the scope of your book, but since I have introduced, and I think it is not a bad idea to know what e is. So let us go through it very fast. You can always stop and see it. I will go the discussion on e very fast. Okay, and maybe I will skip some portion. It's just 2 pages. What e is? So what is e? E is related to compound interest. Okay, so if a bank compounds the money in an account n times a year, suppose it gives every quarterly or every half yearly or after a year, okay, at an interest rate r, and you start with some amount, say 100 rupees or whatever you start with it in the account, and then after a year you will have how much? So if I say that you deposit 100 rupees, after a year you will get 100% interest. That means 100 becomes 200 rupees. So let us say a bank gives 100% interest, that is double at the end of a year. So that means if I have 1 rupee, it will become, after a year, 1 plus 1, that will become 2 rupees. I can write this 1 plus 1 as 1 plus 1 by 1 to the power 1. I will show you why. You will understand why I am writing it like this. And now if every 6 month bank says that they will give the money 2 times a year, then this my 1 rupee after 6 months will become 1.5 rupees. And then after 12 months, that another 50% they will add of 1.5, that is 0.75. And I can express this as 1 plus half, and then this number is 1 plus half of half, that is 0.75. You just go through it, you will understand what I am saying. And I take a common 1 plus half and I can write, and I can express this as 1 plus half the whole square. Okay. And this number is nothing but 2.25. So now every 6 months if they give you, instead of 1 at the end of 1 year, then you have more money. Okay, 1 rupee after the end of 1 year becomes 2.25. But if some bank says, okay, we will give you every 4 months, okay, that is 3 times in a year. So end of 4 months you will have 1 plus 1/3. Then after 8 months it will give 1/3 of this value. After 12 months, 1/3 of this total value. So if you rearrange it, I will not go through the detail, just go through the freeze and see it. Then you will get 1 plus 1 by 3 to the power 3. Okay, that is for every in a year 3 times. If every month it gives, if you go on doing it, you will see is 1 plus 1 by 12 to the power 12. Now the amount has increased 2.61. So amount has increased from 2 to 2.5 to 2.37 to 2.61. And if they say that every day I will give, okay, the same interest, 100% interest for a year, so I will have 1 plus 1 by 365 days, 365, that is 2.71. So you can also say that every hour, minute or second. So this will keep on increasing, but it will not go to infinite value. It will go to some limiting value. It will approach to a value E, and this value of E is approximately 2.78281. This is the value. So I can express this value E as using similar formula, that 1 plus 1 divided by n to the power n, same. Okay, as n tending to infinity, you will get this. So amount A after compound interest is, this is for the first year, is principal times 1 plus r. R is the rate of interest. Okay, and this for 1 year. And so the amount after 2 years will be this amount times this fraction again. So you have a formula for 2 years. This, the principal amount, this n, this is n plus n is 2n, and this 2 is the time. Okay, 2 times it will give that 2 years, 1 year and 2 years. So you can write a general formula like this: A is equal to P 1 plus R by n. N is the number of time interest is applied per time period. Okay, so here I have written A is the final amount, P is the initial principal amount, this is the initial principal, this is the rate, R is the rate of interest, and n is the number of times interest applied per period, say in a year. If only once a year, n is equal to 1. If bi-yearly, then n equal to 2. And t is the number of time periods which has elapsed. So there are more details on the properties of E, which I think is really beyond the scope of this course. So we will not go here. Just I will mention, this is how you plot. This is y is equal to Ex. So for given x, you can, the plot goes like this. When x is equal to 0, e to the power 0 is 1. And then when x is equal to minus infinity, it will go to 0. Okay. And when x is equal to 1, this will have value e here. And it has a property like derivative, that is the slope at each point is the same thing, that is e to the power x, and derivative of e to the power x is same. Here it is, I have written. So let us not go now, maybe in later higher classes we will discuss this property. So let us now skip this much. Okay, if you want, you can freeze this and then later on and see what I have written. So now let us go quickly to what we have done here, that is a to the power m into a to the power n, that is a m times m n. So this is a into a m plus n times. So I can write this as a to the power m plus n. Okay. Go through it slowly what I have written. It is self-explanatory. So 2 to the power 2 into 2 to the power 3 is 2 to the power 2 plus 3 is 2 to the power 5. 2 to the power 5 is 32. Okay. A to the power m, that means a m times to the power n. Now this one n times. So that means you have m into n times. So that will becomes a to the power m into n. It is self-explanatory here. Just go through it, freeze it and see it. So 2 to the power 2, this is 2 square to the power cube. So this is 2 to the power 6. So this is 2 into 2 into 3. So now a to the power divided by a power n. Okay, so I can now do a trick. I multiply and divide by a to the power minus n. I know that a to the power n into a to the power minus n is a to the power n minus n. So a to the power n minus n is 0. So a to the power 0 is 1. And this will be a to the power m minus n. Or simply physically you can see when you have this, it goes up, the exponent become negative. A positive when it goes down, the positive exponent become negative. Or negative exponent when you bring from numerator to denominator, it will change the sign of the exponent. So this is for when m is greater than n, and if m is less than n, then a to the power m minus n I can write like this. Okay, now a to the power m into b to the power m. Okay, this is a to the power m means a m times, b also m times. So I can write a into b, again a into b m times. So it is ab to the power m. So ab into ab into ab m times. So this is, so if it is 2 to the power cube and 3 to the power cube, then I know that it is, first I can write 2 into 3 is 8 and 3 is 9, 9 3 27 is 216. So or also I can write 2 into 3, so 2 into 3 is 6, 6 into 3 is 216. So you see this is a example. Now distributive property, we have discussed this many times. This is the distributive property. So a into b plus c, this is in parenthesis. So a into b plus a into c, you can write it. Okay, suppose we have a plus b, so you can take the whole thing a plus b into c and then the whole thing a plus b into d, which I have written here, and then again you use this and you can get, with this kind of thing I can write a plus b the whole square, a plus 2ab plus b square, and similarly a plus b into a minus b, you just freeze and see as I said. Okay, you will get a square minus b square. So what is this? Root of 3 plus root of 2 into root of 3 minus root of 2, that is root of 3 into root of 3 is 3. So 3 minus, this is 2 square root 2. So 3 minus 2, that is 1. So answer will be 1. So here is a note. Say if a is equal to b square, then one can write b is equal to this is square, I can bring it to the left hand side. So this 2 becomes 1 by 2. So b is equal to a to the power 1 by 2, and that can be expressed as square root a. So here it is, some explanation is given here. Suppose this is true, okay, then my b square should be a. So what I do, b into b is this a to the power half, a to the power half, then half plus half. So b square is equal to a, using this criteria condition. And suppose we use this condition, a to the power m into b to the power m is nothing but a b to the power. Okay, this m are same, so I can bring it here. So here also this b square is equal to this a into a is a square, and this half is common, I can. So this is also equal to. So okay, now we rationalize the denominator. Okay. So any fraction, you have a numerator and denominator. Numerator assigns a number and denominator means it cuts that number to get a denomination, some value. I want to rationalize only the denominator. So I can do 1 divided by root 7, I multiply and divide by root 7, root 7, root 7. So root 7 into 7, root 7 is 7. So I have in the denominator 7, and this is root 7 which is remaining. So this is rationalize the denominator. Okay, here 7, root of 7, so I do again this trick I use. Okay, because I know a minus b into a plus b is a square minus b square. So I divide and multiply by this a plus b, that is 7 plus root 6. So again I get here This is 7 minus 6 is 1. So, and similarly you have to rationalize this. How do you rationalize this? This root of it. So I do multiply and divide by root of 5 minus 2. So you see again here you get 3. We will go this quickly because you can always freeze and see what I am doing. 17 square into 17 to the power minus 5. 2 minus 5 is minus 3. So negative it is exponent. So I can make it positive. Okay, by bringing it from numerator to denominator. This condition we have used. So then 5 squared to the power minus 7 is 7 into 2 is minus 14. You bring it down. 23 to the power minus 10 divided by 23 to the power 7. So this is minus 10 and this plus 7 goes up. So it's 23 to the power minus 17. So I write it as 1 to the power. Just see in the side. Okay, you freeze and see. Similarly here 7 to the power minus 3 into 9. This is common. So 7 into 9 I can write to the power minus 3. So this is just for you all to, I am going quickly because for you to know how to manipulate these exponents. So this is 2 to the power 2 by 3 into 2 to the 1/3. These two are common, so you add. So you get here 2. Similarly 3 to the power 1 by 5 into 4. So 4 into 1 by 5, so it's 4 by 5. So 3 to the power 4 by 5. Similarly 7 to the power 1 by 5 divided by 7. So you bring it up. So you get 7 to the power minus 2 by 15. So 7 to the power plus. The minus become plus. Similarly, go through here also, which I am not going through here. Just freeze and see what I have written here. And if b square is equal to a, we have shown that then b is equal to square root of a. If b cube is equal to a, then we know b is equal to a to the power 1 by 3. If b to the power 4 is n, then we know b is equal to, this 4 will become right hand side. The exponent, if you bring it, there will be a reciprocal here. So this is all reciprocal. So similarly b to the power n is equal to a means b is equal to a to the power 1 by n. So you generally write as this is a square root, then this is the nth root of a. This is a fourth root of, this is a cube root, and this is a square root. So these are all very trivial thing. You should, I think you should freeze this and see what I have written here. I am repeating this again and again, so maybe it may become boring. I will go very fast. I am sure if you read it, you will understand. Like 2 to the power 4 by 2, this 2 will get cancelled, 2 square is 4. Okay, there are many ways of explaining this. Just freeze it and see it. So here I have written a to the power m by n. So I can either take m by n is 1 by n times m. So m I can take first, or I can take 1 by n. Okay, a into b or b into a. So if I take 1 by n first, so I will have nth root of a, then this m to the power m. So if I take m first, a to the power m into 1 by n, so a to the power m is this, then nth root of, so both are same. So that means I can bring this m inside also. So here maybe I have done something to explain it. Go through all this, some exercises. So simplify 64 to this is the square root of 64. 64 is 8 square, okay. This 2, this, so this is 8. And these are for your, in objectives and all, this may be given to you also. You have to practice this. 32 to the power 1 by 5th. 32 is 2 to the power 5. This 5 cancels as 2. Okay. Similarly, 125 is 5 to the power 3. 1/3 is, so 3 cancel 5. Okay. So you just freeze this. I'm repeating this word freeze it, because I don't want to go through it. These are very trivial things. So this is number 2, 9 to the power 3 by 2. I can write like this. That is equal to 27. 32 to the power 2 by 5. You can write 32 as 2 to the power 5. 5 cancel, 2 square 4. So 16 to the power 3 by 4, I can write 16 as 2 to the power 4. 3 by 4, 4, 4 cancel, 2 cube 8. 125 is 5 cube. So Q 3 cancels, 5 to the power minus 1, 1 by. This is 2 into 2 to the power 3 plus 1 by 5. So 5 2s are 10 and 3 into 1 is 3. So 10 plus 3, 13. 13 divided by 5 into 3, 15. Okay. So just freeze it and see this example. You write it yourself in your notepad. Example to check your skill. So this also you should freeze and write it down. X to the power 6 into 4 into x to the power 3. So I take 4 common. So x to the power 6 plus 3 plus 1, 10. So 4x to the power 10. This a to the power 0 is 1. So any number divided by 1 is that number. Okay. So this is a to the power 6 divided by 1 is a to the power 6. So here again, as I said, you go through this example 2, 3, 4. These are good examples. Whichever I find is attractive, I will go for this. Solve for x. This is 3/4 root of x plus 7. So what is x? So I expand this. 3x to the power 1 by 4. 7 minus 1 is 6. So this 3 get cancelled. So this is 2. So x to the power 4 is 2. So x is equal to, this 4 will from, this is the denominator, will go to the other side to the exponent numerator. So this is x is equal to 2 to the power 4 and this, so x is 16. For this, solve this equation, x is equal to 16. Solve for r, v is equal to pi r cube. So r cube is equal to, then r cube is equal to v, this pi you bring in this side. So r is equal to cube root of v by pi. This is the standard notation. I can write scientifically how many I have to, after first digit you put a decimal place. So how many, now the decimal is here. When the big number is there, somewhere decimal has to be there. No? So this is a decimal here. This point, and then if it is 0, 0, 0, that have no value. Okay. So this is point. So 1, 2, 3, 4, 5, 6, 7, 8. So 6.84 into 10 to the power 8. This is a scientific notation. Or if it is 6.8 into 10 minus 5. So as I said, if it's the exponent is negative, then this decimal place will go in the negative direction. So you do this, all are very trivial exercises. This may be given for your objective questions. So as I said, you please freeze it and do it. These are all very similar things. So these also you freeze and copy it and see it. Okay, this 25 is 5 square, 36 is 6 square, p to the power 6, q to the power 8. So now I can write the whole square. So this is 5 square goes here, 6 square, 4 into 2 is 8, 3 into 2. So just have a look. These are all very simple. 27, a to the power 6, b to the power c to the, that is equal to 3 cube. So you can write as, here also it is simple. This into divide by this. So when you do divide, then you can convert the division to multiplication by bringing this denominator to numerator and numerator to denominator. That is what I have done here for xy square cube. And y to the power 0 is 1. Kindly practice this. Okay, take from here and practice this. Here also, just take a screenshot and you can practice this. 17, 18, 19, 20. Okay, this again, this is division. So if you have to multiply, it will become, this quantity will go up, this quantity will come out. That's what I have written here. This is equal to, this quantity is gone up, this quantity is gone down. Similarly, you can prove. Once you see it, what I have written, you will understand. Find r from this volume is 4 by 3 pi r cube. So r cube is 3v by 4 pi. So r is equal to cube root of, mass of a hydrogen atom is given as 1.6 into 10 minus 24 grams. So how many atoms are there in 1 milligram? Okay, 1 milligram is 10 to the power minus 3 gram of hydrogen. So the number of atom will be, this is 1 milligram divided by the weight of one atom. So this many number will be there, 6.25 into 10 power 20. Okay, thank you. We have covered the number system. Next lecture, we will cover polynomial. Okay. So see you in the next lecture.